Hello and welcome to the Autumn 1 Week 2 Chemistry Year 11 exam marking video. Whilst I am going to answer the majority of this paper in black pen, you should have a green pen for adding in points where you lost marks and correcting your work, and a blue pen to add annotations. So the first question. The pH scale is a measure of the acidity or alkalinity of a solution. Draw one line from each solution to the pH value of the solution. Okay, so what we know about acids is that acids have a pH of lower than 7, and there is only one pH lower than 7, which is the 5 up there, so draw a line to that. And neutral substances are pH 7, so draw a line there. You should have got 2 marks there. Very simple question. The next question. Which ion causes acidity when in aqueous solution? So the ion, you have to tick a box, that causes acidity is an H plus ion, and the ion that causes alkalinity, can you think what that is? It's the hydroxide ion, OH negative. Next. When sulfuric acid is added to sodium hydroxide, a reaction occurs to produce 2 products. So sulfuric acid turns universal indicator red because it's got a pH lower than 7. Sodium hydroxide is an example of a base, and that has a pH above 7. And in this case, sodium hydroxide is a metal hydroxide. So it's a metal and then OH. The equation is H2SO4 plus 2NaOH, so OH, the hydroxide group, changes into Na2SO4 plus 2H2O. This is salt, and salt is neutral. Now, the salt that sulfuric acid produces will be something sulfate. What would the salt be if it was hydrochloric acid or nitric acid? Well, the answer is something chloride or something nitrate. Now, this reaction produces 2 products, both of which have a pH of 7. They are both neutral. The name of this sort of equation, acid plus base changes into salt plus water, is a neutralization reaction. Question 1c. How many elements are there in the formula H2SO4, so sulfuric acid? They're asking elements, not atoms. Tick one box. So there's hydrogen, that's the first element, sulfur, the second element, and oxygen, the third element. The answer is 3. What is this type of reaction? So as we said, it's acid plus base changes into salt plus water. Both products are neutral. This is a neutralization reaction. Next, name the salt produced. So, it was sulfuric acid, which produces a salt that has the ending sulfate from the sulfuric. And the metal involved was sodium, so it's sodium sulfate. I'm just going to check that that was the correct metal. Yeah, sodium sulfate. That is the salt produced. Describe how an indicator can be used to show when all the sodium hydroxide has reacted with sulfuric acid. So first you need to add drops of indicator to sodium hydroxide solution, which initially would be purple-blue. Next, add sulfuric acid to the sodium hydroxide solution gradually, and then as the sulfuric acid and the sodium hydroxide react, two neutral products will be produced, and we will know that's happened because when the indicator turns green, we know it's pH 7 and all of the sodium hydroxide has reacted with the sulfuric acid. Now you could write this the other way round. You could write add drops of indicator to sulfuric acid, add the sodium hydroxide solution to the sulfuric acid, and again when indicator turns green, all of the sodium hydroxide has reacted with the sulfuric acid. Write what your mark out of 9 is. Next, hydrogen chloride, HCl, is a gas. Now, hydrogen and chlorine, they're both non-metal atoms, so because they are non-metal atoms and they're bonded together, the bond is a covalent bond and they form a molecule. They want us to complete the diagram to show all of the arrangement of the outer shell electrons of the hydrogen and chlorine atoms in hydrogen chloride. So, here we know that hydrogen has an atomic number 1, so it has 1 electron, and chlorine has the atomic number 17, so it has 2, 8, 7 electrons. That's its electron configuration. So we're only concerned with the outer shell electrons. So we can see, to achieve a stable electron arrangement, hydrogen needs to add 1 electron or share 1 electron, and chlorine needs to either add or share 1 electron too. Now, the hard work has been done for us. We have a hydrogen shell overlapping with the outer shell of a chlorine atom. Now,